Sulfuric acid is one of the most hazardous chemical. We use millions tons of sulfuric acid daily in our power plants just to control alkalinity of the water. So the question arises, what is alkalinity and why it's so important in water chemistry? Alkalinity is basically sum of carbonates, bicarbonates and hydroxide ions. We all know that in our water different types of cations and anions are present. So why is alkalinity in water? Where it is comes? We gain alkalinity in water initially because of CO2 in the atmosphere. When water falls on the surface of the earth through rain, CO2 reacts with that water and add alkalinity in that water. There are basically two types of alkalinity in cooling water system. One is called total alkalinity or M alkalinity, while the other is called P alkalinity. Total alkalinity is basically sum of bicarbonates, carbonates and hydroxide ions. It has been observed that when we add acid in our water, alkalinity initially changes its forms from hydroxide to carbonates, then into bicarbonates. Let's suppose we have added plenty of acid in our cooling water system and pH has dropped to below 4.3. Then what will happen? At that pH, all type of alkalinity will be converted into CO2. So if we have a water sample having pH below 4, it will have zero alkalinity in the system. There will be no M or total alkalinity in that water sample. There is a systematic relationship between pH and M alkalinity. So we can easily predict through that chart how much alkalinity is in our cooling water system or in our maker water system, etc. The second type of alkalinity is called P alkalinity or phenolphthalein alkalinity. We obtain that type of alkalinity at pH above 8.3. So let's suppose we are adding any base or any hydroxide ion in our cooling water system or in any water sample, then what will happen? So that hydroxide ions will initially convert bicarbonates into carbonates and will increase the pH of the system, and we will get P alkalinity in our water sample. So if we have pH below 8.3, then we will not be able to find P alkalinity in that sample. We test P alkalinity in our clarified water if we are adding lime in that water. Ideally 2P minus M should be equal to 0. Alkalinity is one of the most important parameter in our water. If we are maintaining too much high alkalinity, it means we are increasing chances of scaling in our cooling water system, because at too much high alkalinity, all bicarbonates and carbonates will be converted into hydroxide ions, or its alkalinity is around 150 ppm, then bicarbonates will be converted to carbonates, and these carbonates will react with calcium and will form calcium carbonate. So we will observe calcium carbonate scaling in the system. Similarly, if we are maintaining very low alkalinity in the system, then what will happen? All types of the hydroxide ions, carbonate ions and bicarbonate ions will be decreased in the system, and our system will not have so much buffering capacity to handle corrosion in the system. So simply, if alkalinity in our cooling water system is very low, it means corrosion chances are very high in our cooling water system. In short, M alkalinity is basically buffering capacity of water. If we are maintaining sufficient amount of alkalinity in our water, then that water will easily handle minor changes of the pH in the system.